Hey guys, this is just going to be a really quick video describing how I was able to refurbish this Tektronix 2440 oscilloscope, which had an issue with the display. After sitting in the garage for a year, it would actually no longer boot up properly, and it would just show a square or a rectangle in the middle of the screen. And that was actually due to a short from a failing capacitor on assembly board A13, which is a time base where the display driver PCB. As you can see, it's the uppermost board in the assembly, and the failing capacitor was right. Oh crap! I actually lost it here. It was right here. So you can see I already desoldered it because it was only a bypass, or sorry, not a bypass, a smoothing capacitor from basically across a 15-volt rail to analog ground for a transistor. I just didn't bother replacing it since I didn't have the proper capacitor value to replace it with. Okay, and how I was able to figure out which one it was first I measured from test point 602, which is a plus 15-volt rail, to analog ground. I removed every single cable connecting to this board, and it showed basically a dead short. So then I just opened up the service manual, and also I just measured each capacitor on the board using my multimeter. I set it to ohms, and then I just checked to make sure and check to see which one's basically open, or sorry, which one's shorted, essentially. And I ended up with about 8 or 9 in total that was showing basically close to 0 ohms, and those are all the ones across the 15-volt rail to ground. I ended up cutting the leg for one end of each capacitor one by one, and then I would measure across this 15-volt rail and analog ground every time I cut one to make sure and check to see if the short has been resolved. So I started by cutting this one. There was quite a few that I've ended up cutting, and then eventually I found out that it was this one that was causing the shorts after I cut it. So that was working afterwards. There was a ton of errors, so I ended up clearing the NVRAM that cleared up all the errors. So now, since this is such an old scope, obviously the built-in lithium-ion battery in the NVRAM is actually potted inside the actual module. As you can see, that would be this board right here, and these are the modules. So what you actually have to do to get to replace the built-in battery on these, if you have one of the newer model, quote unquote, of the 2440 or the newer revision, because the older revision actually had a battery right here that the newer revisions don't have, is you actually have to get yourself, the easiest way is to get yourself a hot air gun, okay, with a very, very thin nozzle. And what I have done is to basically crank this up to about 400 degrees Celsius. And then, so obviously you have to desolder it, both of these modules from the board. I used just some desoldering wick, and then that took me a bit of time, but eventually I was able to get both of them off without damaging it. And so once you've gotten them off, you would get your hot air gun. Okay, and then you would basically focus your hot air to, there's 2 bumps on the underside of this module here, and that's the 2 lithium-ion batteries that were built in. And so you would, I would recommend doing the rightmost one, because that one is easier for you to wire up. So you would hold the hot air gun over, and a bubble will start forming. Then you can just get your tweezer or your whatever sharp object you really have, and then just start peeling it off, peeling the topmost layer of this potting gunk off. Once you have done that, you would be able to see the battery, the top side of the battery, and you would just keep peeling it off, apply some heat, and then eventually you will be able to get the top of the cell pretty much cleaned and cleared off. Then there is a tab that's spot welded onto the cell. You would basically take your tweezer and just roll it off. So you would hold it at the end of the tab and then just roll it off. That would be your negative terminal. And then also you need to actually remove the entire battery to access the positive terminal. So what I've done is to just heat up the battery, which is kind of dangerous. If you want to spend more time on it, you could start use the same hot air method, and then you would just clean the entire area around the battery. But otherwise, you could theoretically just put the hot air directly on to the top side of the battery, and eventually the battery will get hot enough for you to just basically pry from the underside of the battery and just pry the entire battery out. And that's how I've been able to get the battery out, and the underside there would be the positive terminal. So I just soldered, you can see I soldered 2 wires on there, the ground wire to the top tab right here, and then the bottom, this red wire is soldered to the positive terminal, and I've done that for both. I've also ordered some 28-pin dip sockets. You actually need to order the one that's 15.94 millimeters wide. That's a wider variant. There's also one that's half the size, which is too short. These are really wide modules, so you need to order the wide 28-pin dip sockets. So I'm waiting for those to arrive, and once they arrive, I'm going to solder the sockets on instead of just soldering this directly in there, so I can access it if it doesn't work. And I've also ordered some CR2032 battery holders, so to replace these really tiny cells. Hopefully I wouldn't need to replace it for like 20 years, so that should be good. And yeah, that should be good to go. Once that's done, you just need to reassemble everything, obviously, and then you would run the self-calibration. And also, if you have equipment to do so, you can also run the external calibration. And I know a lot of people make a huge fuss about actually maintaining the NVRAM data on here by copying it first. But since this module I've had is so old, the battery is completely dead. In fact, if I measure this cell, I've done it before, it's measuring like 0.7 volts. So it's obviously gone already, but it's also not really necessary for you to retain the data, in my opinion, or the calibration data, because it's so easy to calibrate it. It's really not worth the entire effort of trying to preserve the calibration data. So yeah, that's all there is to it. If you've also got yourself a really old Tektronix scope and you ran into a similar situation, I hope this video was able to help you out. Thank you and take care.